So that was content-based, but what about datasets we could create for the movie web pages that use collaborative filtering? Just as with content-based, these could be structured or unstructured, and also be explicit feedback or implicit feedback. Of course, for collaborative filtering to work, it requires users to interact with items. Otherwise, we can have a cold start or sparsity problem. Let's say for this hypothetical example that there is abundant user-item interaction. So now let's pause again while we think about what datasets we could use for collaborative filtering recommendations, and then we'll go through some of the ones we came up with. All right, let's see some of the ideas we came up with. The most obvious thing to use for collaborative filtering is, of course, user ratings. Now, this website might not have a way for users to leave explicit ratings, and would have to resort to more implicit means of feedback, but for this hypothetical example, let's assume there are ratings. As we know with collaborative filtering, these ratings will be used to create user and item factors within a rating embedding space of latent features that we can then use to make recommendations. We can also use implicit feedback, such as user views. We can assume that a user ended up on a movie's web page for a reason, that some interest led them there. Perhaps instead of just a flag if a user has visited a movie's web page, we can keep track of the number of times they visited that page. This goes with the assumption that if a user visits a movie's page more frequently, they have more interest from movie pages that they don't visit frequently or at all. There's also the user wish list cart history that we could use. This is an interesting data set. Think about the wish list. It is implicit because it's not explicitly saying that a user likes the movie, but that they think they might like it enough to add it to their list. Also, the cart history is another step further. The user has actually now selected the movie for purchase and they just need to check out. As a lot of us do though, putting something into a cart doesn't mean we'll buy it. But it is just another interaction, another signal that this user might like this particular movie. Going one step further, we can use the user purchase history as implicit feedback, because we still don't know whether they like or dislike the movie, but it is an interaction. However, we may be able to also use a user's return history as a proxy for dislike, because it's probably more likely that someone will return a movie that they don't like, over potentially other reasons that are more rare, like the movie is broken, wrong language version sent, etc. There's also unstructured data that we can use for a collaborative filtering model. One type is user reviews. These will be free text that we can apply natural language processing to in order to gain some idea of sentiment. Unlike content-based professional reviews, these are written by users that we can find similarities to in order to make recommendations from. We can also try using user-answered questions as data for a collaborative filtering model. These can be a little bit tricky. A user answering a question doesn't mean that they like the movie. In fact, their answer to a question could indicate that they don't like the movie. So we could just use a yes or a no flag, or the number of questions answered for each user for that movie as implicit feedback, because answering is an interaction, similar to using user views. We could also run sentiment analysis in the answers, and although most would probably be flagged as neutral, some may show as positive and others negative, which might be enough extra signal to improve our recommendations. There could also be user-submitted photos for some movies. This might apply more to people buying items, submitting pictures of the item all assembled, etc. However, perhaps people show how the movie looks on their brand new TV, or they take pictures of themselves at a movie viewing party with their friends in their home theater. All of these scenarios are data that may or may not add some signal to improve recommendations. We can use the fact that someone uploaded a photo at all, or the number of photos they uploaded, as a form of implicit feedback. We could also use an image model to create trained labels that might convey some form of sentiment. The same goes for user-submitted videos, where we can use the fact that they interacted as implicit feedback and/or can process the video with other machine learning algorithms and use that now structured interaction data.